Hello friends, today we will discuss about the leveling methods. So as you know, there are two methods. One method is height of instrument method and another method is rise and fall method. But before we discuss that two methods, first of all we will discuss some definition, and that is very important to understand this all the definitions. So you can see here, I have written here some definition, or you can say some special terms which is used in the leveling. The first one is datum surface. What is that? It is a level surface whose elevation is known or assumed. It is called datum surface. The vertical distances of different point above or below this line are measured from the datum surface in a vertical plane. So this is the basic definition of datum surface. Second definition, that is about the reduced level. In short term we call as a RL. So what is that? The vertical distance of a point above or below the datum surface is known as the reduced level of that point. So here what we are doing, we are taking the vertical distances from the datum surfaces. Sometimes above the datum surface, sometimes below the datum surface. So that is called reduced level. I have put here one figure, and you can see in this figure that all the process which we generally do in the field is presented here. So I will explain this figure later on. First of all, we will discuss all the definition and then come to this particular figure. Another definition is benchmark. Short form is BM. So what is benchmark? The benchmark is a fixed point of non-RL above the datum. A point whose RL is known can be used as a benchmark. So whenever we do this leveling operation, we have to always select one benchmark, and that is always permanent benchmark, means whose RL is known to us. You can take any example, for example, railway platform, okay, pillars, age of the building. This all the structure you can take as a benchmark, permanent one, whose RL is known to us. That is very important. After that, station. Another definition is station. So what is the meaning of station in leveling? In leveling, a station is that point where the staff is held and not the level is set up. Okay, means on station, leveling staff is kept for the purpose of determining its elevation. So we call as here as a station. Then another definition, that is the backside. We call as a BS. What is that? This is the first staff reading taken after setting up the instrument. Okay, whenever we do the leveling, okay, you know very well what is the leveling. In that we have to do some initially some procedure. That is the one of the procedure is that we have to do the temporary adjustment of the level. Okay, we have to do the centering, leveling, etc., etc. And then once we are ready to take the reading, the first reading that we are taking, first staff reading after setting the instrument, that is called backside. And this reading is always taken on a point of non-elevation, RL. Okay, means on a benchmark or change point. Another word is change point, that we will discuss later on. So first reading which is taken on a non-point of RL, that is on a benchmark, is called backside. And backside is used to determine the height of instrument. And that is the method that we will discuss today in this particular lecture. So this BS is very important to determine the height of instrument. The BS is also known as the plus side because it is always added. So suppose if you want to calculate height of instrument, how will you calculate? It is equal to non-elevation plus backside. You just add the backside value. You will get height of instrument. Next one is foresight reading. Once we take the backside, we have to take number of readings. Okay. So in that number of reading, one of the reading is foresight reading also. So what is the foresight reading? FS. Short form is FS. It is the last stab reading in any setup of the instrument. And it indicates the shifting of the level also. The FS is used to determine the elevation of stab also. Meaning is that first reading is called backside. Last stab reading is called as a foresight. Whenever you take last reading, means when you will take a last reading, when you end your leveling activity. Suppose at the end of the day, you are thinking that now I have to over my leveling operation and you will take your last reading. This last reading we will call as a foresight reading. Another thing is that suppose if you are shifting your instrument from one position to another position. So before shifting that instrument from that particular position, whatever last reading you will take, that is called foresight reading. And how will you calculate? RL of station is equal to nothing but RL of HI, height of instrument, minus FS, that is foresight. So if you want to calculate the RL of that particular point, what you have to do? You have to just deduct your foresight value from RL of HI. Then intermediate side, that is called IS. So as I told you, we have to take so many readings. So first reading we call as the backside. Last reading that we take it called foresight. And in between whatever number of reading you will take, that is called IS. Actually, what we have to do? We have to prepare one survey book, field survey book. So in that number of columns are given. Okay, station, backside, IS, foresight, RL, remark. So whatever reading we are taking, we have to enter in that particular column. So here intermediate side means it is in any other stab reading between the backside and foresight in the same set of the instrument. And the IS is used to determine the elevation of intermediate stab station. So same way, if you want to calculate the RL of that particular station, what is the RL of that station? RL of HI minus IS. So change point. Next definition is. So what is the change point? The point indicates the shifting of the instrument. At this point, before shifting the instrument, foresight is taken, and after shifting the instrument, backside is taken from the next setup at the same stab position. So as the name suggests, change point means we have shifted our instrument from our existing position to new position. So when we change our setup from our existing position, we have to take the readings. And that reading is called as a foresight reading. Because for that particular existing position, whatever reading you have taken, that is the last reading. And as you know, we have already discussed that last reading we always call as a foresight. So as here written, at this point before shifting the instrument, we will take one reading that is called foresight, means you have to enter in your foresight column. And after shifting the instrument, means you will shift your instrument at a particular new position. And from that new position, you have to again bisect that particular stab again, but from the new position. And whatever reading you will take, that is called backside. That is our first reading, because for that particular new position, that will be the first reading. That's why we call as a backside reading. And this particular point where you already put your staff and you have taken foresight as well as backside reading, that particular point is called change point. So at change point you will get two reading always. One is foresight, another is backside. Okay, so come to our that figure. Okay, so this is one of the example I have put here. You can see here benchmark is taken and some value is written 49.873, and you can see these all are your staffs that you have put at some interval. Okay, this is your ground, undulating ground. It's not a always you will find level ground. It will be somewhat undulating ground. So as I told you, you have to do your setup, you have to do your some temporary adjustment of the level, and once you complete this all the activity, then you have to take your first reading. Okay, so you can see here this tripod, you can see that means here to show you, and this is your level. It will be auto level or dumpy level, and this is line of sight. Okay, so this is the first staff reading that we are taking, and you can see here written is BS, and that will be somewhat 2.191. Okay, so you have to take the reading. Then once you take that backside reading, then you have to take at some interval some various readings. So you can say afterward here one staff is putted. Okay, and some reading is taken 2.505. Okay, then again here one staff is putted and one reading is taken, that is 2.325. Okay, and after that what they have decided that now I have to change the instrument position from this particular point. Okay, so this particular point is called as a change point. So before shifting this instrument from this particular position to this particular position, I will take this staff reading, and this staff reading I will call as a foresight. Some value is there, and then I will shift my instrument from this position to this position, and I will again bisect the same staff. This staff I have bisected here, and when I shift my instrument from this position to this position, I have again bisected the same staff, and that reading will be called as a backside, because for this particular position this will be the first reading. So 3.019. So you can see here this is particular change point, you are getting two reading, backside and foresight. So this is your change point. Now you have to repeat your same procedure. You have to take another reading, that will be your IS. Then again here they have taken one reading, that is your foresight. Again they have taken here change point. Means this instrument now shifted from this position to this position. So what you have to do, you have to take the reading, but that reading, this reading will be entered in a foresight column. And once you shift this instrument from this position, again you have to bisect same staff, but this reading will be called as a backside. You can see this is a line of sight. Okay, this is a line of sight. And then I have decided that this is my last reading for this particular leveling activity. So this will be your foresight value. Okay. Secondly, you have to also calculate height of instrument. We will discuss also. So here you can see here benchmark is given 49.873. If you add this value to this particular backside value 2.191, you will get your new height of instrument. And once you get your new height of instrument, and if you want to calculate RL of this all the point where you put it on your staff already, what you have to do, you have to deduct your IS value from your height of instrument, you will get RL of this particular point. If you want to get RL of this particular point, what you have to do, you have to deduct the IS value from this particular point. Okay. So now steps in leveling. Okay. So there are two steps. First one, to find by how much amount the line of sight is above the benchmark. Okay, this is a line of sight. So how much amount the line of sight is above the benchmark, and second one, to find by how much amount the next point, that is this point, is below or above the benchmark. Okay, So you can see this simple figure is given. Benchmark, these are 2 point P and Q. This is your instrument. This is a line of sight. Okay, 0.525, 0.245. So actually, we have to calculate RL of HI, and simultaneously we have to also calculate what is the RL of this particular point, what is the RL of this particular point. Suppose if you take number of, actually this is your benchmark, but suppose if you take here number of stops, and if you want to calculate what is the RL of that particular point, you can calculate easily. So you can see a level is set up approximately between the benchmark. A level is set up approximately midway between the benchmark or change point and the station, the RL of which is to be determined by direct leveling. There are so many methods of leveling, you know very well: direct leveling, fly leveling, check leveling, profile leveling. Okay, so this we will do using the method of direct leveling. So a backside is taken on the staff held at the benchmark. As I told you, whenever we start our leveling operation, we'll put our staff on a point of non-RL, that is the benchmark, and that is the first ring, that is called backside. So how will you calculate RL by HI? Height of instrument, RL of benchmark plus backside. Turning the telescope to bring into the view the staff held on point Q, and that will be your last reading. So foresight is taken. So if you want to find what is the RL of that particular point Q, what you do? You have to deduct your foresight value from RL of HI. So RL of HI minus foresight. For example, here I have put one example also. If RL of benchmark P is given 100 meter, backside is given 0.525 and FS is given 0.245 meter, then what will be RL of HI? RL of benchmark, that is it is given 100 plus backside is 0.525. So you just add this two value, you will get 100.525 meter. And now if you want to calculate RL of Q, what will be that? RL of HI minus FS. So what is RL of HI? It is 100.525. 100.525 minus FS. What is your FS value? It is given 0.245. So 0.245, you will get 100.280. Okay. So let's come to our methods, and we'll take one example also. Recording and reducing, that is the reduction of level. Recording and reduction of the level may be done by the following two methods. The collimation or height of instrument method. It is also called collimation method or height of instrument, that is HI. And second one is rise and fall method. So now there is one comparison given between HI method and rise and fall method. There are 5 points are listed. You can see in HI method, what is that? It is more rapid and saves time and labor. Whereas in the case of rise and fall method, it is a laborious, involving several calculations. Second point, in HI method, there is no check on the RL of some intermediate station. Whereas in the rise and fall method, there is a check on the RLs of intermediate station also. In HI method, error in intermediate RLs cannot be deducted. Where in the case of rise and fall method, errors in intermediate RLs can be detected. Now, fourth point, very important. There are two checks on the calculation of RLs, that is summation BS minus summation FS is equal to last RL minus first RL. Whereas here, there are three checks. Instead of two, here there are three checks, that is summation of BS minus summation FS is equal to summation rise minus summation fall is equal to last RL minus first RL. And fifth point, in HI method, this method is suitable for profile leveling where there are a number of intermediate sites. Whereas here, this method is suitable for fly leveling where there are no intermediate sites. Okay, so this is one comparison between HI method, rise and fall method. You have to remember this, all the points. Now come to our methods. That is first one, height of instrument method. It is also called line of collimation method. Short form is HI. So reduced level of the line of collimation is said to be height of instrument. The following are the different steps to be followed in the method. The first, the height of instrument is calculated by adding the backside reading to the RL of benchmark. As I already told you, that is RL of HI is equal to RL of benchmark plus backside. Secondly, Before shifting the instrument, the RL of intermediate points and change points are obtained by subtracting the respective step reading, that is IS or FS, from the RL of HI. So if you want to calculate RL of intermediate points, what will that? RL of HI minus IS. And if you want to calculate RL of change point, what will be that? RL of HI minus FS. Okay. So by this way, we can calculate all the RL of points. Third one, the level is shifted for the next setup. Then the level is shifted for next setup, and again the new height of the instrument is obtained by adding the backside ring to the RL of change point, which was obtained in the first setup. Now you have already changed your instrument, okay? And once you change your instrument to new position, you have to calculate your height of instrument again. And here instead of benchmark, RL of benchmark, you have to take the RL of change point. So RL of HI is equal to RL of change point plus backside. Why we have to calculate height of instrument again? Because at previous location where you already done your setup, level will be different. And the new position again level will be different. It might be somewhat at higher location or it might be somewhat at a lower location. So whenever you change your instrument, you have to always calculate new HI. Fourth one, the height of instrument is different in different setups of the level. As we already right now discussed this point. And for a change point, FS reading is taken before shifting the instrument and BS reading is taken on the same step position after shifting instrument. So this point we have already discussed. So now we take one small example. Okay, and then we see all the calculation. So you can see this type of columns are given: station, backside, IS, intermediate side, foresight, HI, RL, remarks. Okay, actually right now we are discussing about the height of instrument method. So this is the procedure how to follow this particular method. So first of all, actually what you have to do, you have to enter all the readings. So we'll take one more example after this particular example. In that I will tell you how to enter all the reading in that particular column. Okay, but before that we just see this particular example. So you can see benchmark is given, then station points are given 1, 2, 3, 4, 5, 6. You can see first backside value is given 1.250. Then IS value given, then another IS value is given, and then here you can see change point is taken. So this will be your last reading for the particular existing position. And then when you shift your instrument to new position, you have to take again you have to again bisect the same stuff and you have to take the new reading, that will be your backside. So here you are getting the two reading, that is your change point. Again you have to do same procedure, you have to take number of intermediate side, and this will be your final step reading. Okay, now you can see here you have to calculate HI. RL is already given for benchmark, that is 100. Okay, so how will you calculate RL of HI? We already discussed RL of HI will be calculated by RL of benchmark plus backside reading. If you add this 100 plus this value, you will get your HI value 101.250. Now what you have to do? These all are your stop position. Okay, 1, 2, 3, 4, 5, 6, and you have to actually calculate the RL of all these station point. So how will you calculate in HI method? Once you get your height of instrument value, you have to deduct this IS value from this height of instrument value. You will get RL of this particular point, that is 99.690. If you want to calculate RL of this second per station, what you have to do? You have to deduct this IS value 1.750 again from your height of instrument. So you will get 99.500. If you want to get what is the RL of this particular station number 3, again you have to take your foresight value and you deduct from HI value. So you will get RL 99.150. Now you can see here we have taken the change point. And as I told you earlier, whenever you take change point, means you are shifting your instrument from new position, existing position to new position. You have to again calculate new HI. So how will you calculate new HI? RL of change point, not RL of benchmark. RL of change point plus backside reading. You will get new HI, that is 100.500. Now once you get 100.500, it is the second HI for new location. And if you want to calculate RL of this, all the point 4, 5 and 6, you have to deduct your 1.110, this value, from new HI, not from this value, from new HI. So 100.500 minus 1.110, you will get this RL. Then for this 5 number station, 100.500 minus 1.265, you will get new RL. And then for 6 number station, 100.500 minus 0.985, you will get new RL, 99.515. Okay. Then what you have to do? You have to do the summation of this all the backside value. You can see 2.600. You have to do the summation of all the foreside value, that is 3.085. You can see this figure is given here, so you will understand easily this all the calculation. So this is our benchmark whose value is 100, and this is my instrument setup. This is my telescope. Okay, this is my line of sight, and I have put my staff here, and I am taking my first staff reading, that is the back side. So I will get my RL of height of instrument. How will you get? 100 plus 1.250, 101.25. Then I have put my staff at various location. Here 1 number, station number 2, okay, station number 3, 4, 5, here also. So for station number 1, what is the IS value? You have to bisect this staff, you will get one reading, that is 1.560. Then you have to bisect this staff, you will get again, you will get IS value 1.750. Then again you have to bisect this staff, you will get again one value 2.1.0. But it will be called as a foresight value, because we are shifting our instrument from this position to this position. So before shifting the instrument, whatever staff you are bisecting, that reading is called foresight. Once you put this staff to this position, and again you have to bisect the same staff, but for this reading will be called backside. And here you are getting two reading, backside and foresight. This is called change point. Then again you have to bisect this staff, both are called as IS value, and this will be your final reading, means last staff, and you are taken the last reading, that is called foresight. Once you take this all the readings, what you have to do? You have to calculate the RL of this point 1, station number 1, station number 2, then this station, then you have to calculate this station. So what you have to do? Just you have to deduct this all the IS and foresight value from your HI value, and you will get respective RL. And whenever you take change point, you have to take again new HI. So RL of change point plus backside, you will get new HI. And once you get new HI, again you have to do same procedure. You have to do all the IS and foresight value from this particular HI. You will get respective station RL value. You can see calculation is already given. I have already explained you also. But again, you can see just for reference, RL benchmark is 100. So RL of HI, what will be? RL of benchmark plus backside, 100 plus 1.250. That is 101.250. So RL of 0.1 station, how will you get? RL of HI minus IS value. That is 101.250 minus 1.560. I have already explained this, all the things. So this calculation I will given for your reference, RL of 0.2. Again, what you have to do? You have to do IS value of that second station from RL of HI, you will get RL of that particular point. Then same way RL of 0.3. And once you change, you have to take the change point and you have to again calculate new height of instrument. So as I told you, RL of HI is nothing but RL of change point. Instead of benchmark, you have to take RL of change point plus backside. So 99.150 plus 1.350, you will get new HI. And once you get new HI, RL of station 0.4, RL of station 0.5, RL of station 0.6, you can get easily by correspondingly detecting IS and foresight value from the RL of HI value. And once you calculate these all the things, finally you have to do the arithmetic check that we have already seen in comparison also. And what is that? The difference between the sum of the backside and sum of the foresight should be equal to difference of the last RL and first RL. Means summation BS minus summation FS is equal to last RL minus first RL. What is summation BS? We already seen in the previous, right? Just this is summation BS, that is 2.600, and summation FS is 3.085. And what is your last RL? This is your last RL. And what is your first RL? This is your first RL. Okay. So I have put the value 2.600 minus 3.085, 99.515 minus 100. You can see here minus 0.485 is equal to minus 0.485. Both the side we are getting same value. So once we get the same value on both the side, our example is correct. This check verifies the calculation of the RL of the HI and that of the change point also. And there is no check on the RLs of interpoints. So that is the limitation that we know in the item instrument method. So this is all about the item instrument method. Now we will discuss about the rise and fall method. So what is the rise and fall method? In this method, the height of instrument is not at all calculated, but the difference of level between the consecutive point is found by comparing the staff reading on the 2 points for the same setting of the instrument. Means suppose, you can see one example is given here. If the forward staff reading is smaller, this is your forward staff reading, that is B. Forward staff reading is smaller than the immediately preceding staff reading. This is your immediately preceding staff reading. It indicates a rise. Means this is the level and this is the another level. You can see if you, this is your datum surface. If we go this way, this much rise you are getting. Means RL of point B is nothing but RL of point A plus rise. Okay, so that is your rise. And if the forward staff reading means this, that is B, is greater than the immediately preceding staff reading means this A, then it indicates the fall. Means RL of point B, if you want to find, is nothing but RL of point A minus this difference, that is the fall. So this is the meaning of rise and fall method. The rise is added to the RL of preceding point to get the RL of the forward point, and the fall is subtracted from the RL of preceding point to get the RL of forward point. So you can see one figure is given as well. Benchmark is given 100 point. This is your undulating ground. This is your setup of the instrument. This is your telescope, and this is your backside in 0.675 value is there. Then you have taken the IS value. Then you have taken the foresight value. Then again here change point you are taking. Okay. Then again IS value, foresight value. So how will you do the calculation? The specimen page of the level book. So same way we do the calculation in a tabular form, but you can see this column will be added. Instead of HI, here 2 column will be added. Station, backside, IS, foresight, rise and fall, RL and remaining column will be remain as it is, but instead of HI, I will add here 2 column. Rise indicate, in mathematical term, it is indicate the positive and fall indicate as a negative. So we will discuss the example. So you can see backside value is given 0.675. Okay, IS value is given 1.465, foresight value is given 1.785. Then again here change point is taken, so again backside value 1.250, IS value is given 0.850. This will be your final reading, that is the foresight value 0.350. So now in rise and fall you can see we have to take the level difference between the 2 station point. So you can see for benchmark value is given 0.675 and for station P value is given 1.465. So we have to take the level difference of these 2 points. And when you take the level difference of these 2 points, and if you find your answer in negative, means that indicates the fall. There is a fall. And that value you have to enter in the fall column 0.790. We don't mention the sign because we already mentioned here that fall indicates the negative and rise indicates the positive. So you have to just take the level difference of this 2 station point, that is the benchmark and point P. Then you have to take the station P and station Q difference. Again, if you take the level difference of this 2 station point, you will find your value negative. That indicates that there is a fall. There is a valley area 0.320. Then again you have to start from this position because you take the change point, means you have taken your first reading. So you have to start from again here and you have to compare station Q and station R. You have to take the level difference of this 2 station point. If this value come positive, you have to enter in this column, rise column. This positive value indicate that there is a hilly area, there is a rise. Then you have to compare station R and S. You have to take the level difference of this 2. Again you will get positive value. You have to enter in rise column. Again this indicates that there is a hilly area. So by this way, you have to calculate rise value and fall value. You have to take the summation all the backside value, all the foreside value, all the rise value, all the fall value, because this will be used in a arithmetic check. Now regarding the RL, this RL is already given to you. You have to calculate the RL of remaining station P, Q, R and S. So how will you calculate? In this rise and fall method, once you know the RL of this particular first point, benchmark 100, then what you have to do, you have to take this value 0.790, which is your fall value, and you have to deduct this fall value from this RL benchmark. You will get RL of this point P, 99.210. Okay, once you get 99.210, and to get the RL of station Q, what you have to do? You have to again deduct the 0.320. Why we are deducting? Because these are the fall value. Suppose here, rise value is there, then you have to add. So here 0.320 we have to deduct from this value, not from this value, from the current RL value. So 99.210 minus 0.320, you will get new RL 98.890. Once you get this RL, and if you want to get RL of R station, what did you do? 98.890 plus 0.400, not minus, because here we are adding rise value. So 98.890 plus 0.400, you will get 98.290. Then 98.290 plus 0.500, you will get 98.790. That is the RL of last station, that is the station S. Okay, so by this way you have to do all the calculation. Okay, this again I was on one calculation sheet, that point P that we already mentioned in figure, that is your benchmark. So 0.7, 0.675 minus 1.465, you will get 0.790, that is your indicate the fall. Then point Q with respect to P, means you have to take the difference between P and Q. So you will get again the minus value, that is your fall value. Then you have to take the point R and point Q, and then point S and point R. So the two value are rise value. Okay, and then how to calculate RL of point P, RL of Q, RL of R and RL of S, that I have told you. And then last one, that is regarding the arithmetic check. So difference between the sum of the backside and sum of the foreside should be equal to the difference between the sum of the rise and sum of the fall, and should be equal to the difference between the RL of last point and first point. So we already discussed, we already seen also, summation BS minus summation FS is equal to summation rise minus summation fall is equal to last RL minus first RL. So you have to put your summation BS value 1.925 from the table, this value also from the table, this value also from the table, this value is also from the table. Last RL, we already seen what is last RL in this case. This will be your last RL 98.790, and this will be your first RL 100. Okay, so 98 is not 99 here, 98.790. This is one mistake. 98.790 minus 100. And once you do this, you will get minus 0.210 is equal to minus 2.210 is equal to minus 0.210. You can see all the three segments we are getting the equal reading. So in this method of reduction, a complete check on inverse side is also provided, because there are included for calculation the rise and falls. Okay, so once you get this all the readings equal, then your arithmetic check is okay, your example is also okay. Okay, arithmetic check is meant only for the accuracy of calculation to be verified. It does not verify the accuracy of the fieldwork. So that point you have to always keep in mind. So as I told you earlier, table is given, but suppose if table is not given to you, you are in a field, you have to prepare your field book. So how will you enter your reading in that particular table? So that example I have taken here. So again we take one more example for your understanding purpose. So you can see readings are given. The following consecutive readings were taken with a dumpy level along a chain line at a common interval of 5 meter. Okay, at a 5 meter interval we have taken all the readings. The position of the instrument was changed after 3rd, 7th and 10th reading. Draw out the form of a level book, means you have to prepare your level book, and enter the above readings properly. Assume the RL of the first point as 50. Calculate the RL of all points and apply the usual checks. Use HI method and rise and fall method. So you have to solve this example using two methods that we have discussed, HI method and Reisenberg method. And these are all your data: 0.350, 0.580, 0.645, 1.850, 1.935, 2.450, 1.750, 0.360, 0.720, 1.20, 0.920, 0.630. So how will you do the calculation? Okay, so these all are your step reading. So as I told you, first of all you have to prepare your table. So we already discussed that whenever we take the first step reading, that we will call always as a backside reading. So you can see here I have written here 0.350 and it is reading number 1 and it is called backside. So you have to write this way. Then second reading is 0.580. That is second reading 0.50, but that will be your IS. Once you take backside, the remaining reading will be entered in a IS column. Then third reading will be 0.645, but I have put here FS. Why I have put here fourth reading? Instrument was changed after third, 7th and 10th reading. Third, 7th and 10th reading. So here I am changing my instrument from this particular position. Step will be remain same, but instrument position will be shifted. So before shifting the instrument, I will take the reading, and that reading will be called as the last reading for that adjusting instrument. So for that purpose, I have written 0.645 as a foresight value. Immediately fourth reading will be entered in the backside because you are setting the same step from the new position. So that will be your backside. Okay, so like you have to write this way. Then again your fifth reading will be IS value. Sixth reading will be again IS value. Seventh value will be again foresight because you are all again changing your instrument station position. So that will be your entered in a foresight column. But immediately after that, eighth will be entered in a backside column. Okay, because change point is there. Again, ninth will be your IS value. 10th station, again we are taking the change point. So that will be last reading for that particular existing station. So that will be entered in foresight. And again, at a new position, you have to bisect the same step. So that will be entered backside. And this 12th number reading, it is written as a foresight. Why? Because there is no intermediate readings. Immediately after backside, I am taking my final reading for the ending of the day. If you take suppose some readings, then here some intermediate side will be there, but there is no reading, so this will be your last reading, and that will be called as a foresight. Okay, so once what you have to do, once this value you will take from the field, you have to arrange this in a tabular form. So I have arranged my all the tail readings. Okay, and I have mentioned also why it is called foresight, why it is called backside, why it is called IS, and why it is called foresight. Okay, so this all the instruction I have written here that I have right now told you. Okay, so you can see height of instrument method. So first of all you have to write down the station, chainage, backside, IS, foresight, HI because we are right now doing the calculation based on this method, then RL and remarks. Here one more column is we have added HNH because in data it is given that these all are taken as an interval of 5 meters. So what you have to do, first of all you have to write down the station point 1 to 9, then you have to write down. But my suggestion is that before you use this 2 column, you just first of all enter this 3 column value, and then you enter the station and chainage value. Otherwise you will get confused. You will do some mistake. So don't touch this 2 column. First of all you put the value in this 3 column, backside, IS and then you put the value here. So for backside, as I told you, first reading, so 0.350 I have entered here. Then second reading, already I have marked that I have to enter here 0.580 in a second row. Okay, in a second row, second station. Then third value I have mentioned, it is in foresight, so I have to enter in foresight column. Okay, you can just see I have mentioned here. I'm just showing you this first reading, backside, second reading, IS, third reading, foresight, fourth reading, again backside, fifth reading, IS, sixth reading, IS, seventh reading, foresight, eighth reading, backside, ninth reading, IS, 10th reading, foresight, 11th reading, backside, 12th reading, foresight. So already I have done this. So you have to just enter the value. This is my third reading. Then again immediately fourth reading will be my backside. fifth reading in IS, sixth reading in IS. Okay, then seventh reading again foresight, eighth reading again backside, ninth reading again IS, 10th reading again foresight, 11 again backside, and 12th again foresight. This is the last reading, so foresight. You have to enter this all the value, then you enter the station value 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 stations. Why I told you enter this? Because there are 12 readings and station are only 9. So there are sometimes it happens that you make some mistakes. That's why I told you that you enter station point at the end. So once you enter this all the value, then you enter the station value 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you enter the change value at 5-minute interval 0, 5, 10, 15, 20, 25, 30, 35, 40. Okay. So we have completed up to this stage. You also do the summation of this all the readings of backside, and you also do the summation of foresight value. Then you have to calculate the HI value. Okay. So how will you calculate? We already discussed this one example. RL of benchmark is given 50. And you have to calculate HI. So how will you calculate? We already seen the theory. We already seen the formula. RL of HI is nothing but RL of benchmark plus backside. So you will get RL of HI. I already explained the figure also. Okay. And once you get the RL of HI, and if you want to calculate the RL of this all the stations, what you have to do? You have to deduct this 0.580 of second station from this RL of HI. You will get RL of second station, that is 49.770. Okay. Then you have to take this third station value, that is the foresight value 0.645. You have to deduct this value from RL of HI 50.3.5. So you will get again RL of third station 49.705. Now here we have taken the change point. And as I told you, whenever you shift your instrument to new position, you are taking the change point. You have to again calculate the new HI. Why? Because the level difference is there. This instrument setup is particular. This here some level is there. Here you are taking, suppose you are shifting your instrument to some higher level, or sometimes you are shifting your lower level. So there will be chances that your HI will be changed. So whenever you take change point, you always remember you have to calculate new HI. So here how will you calculate? RL of change point, not RL of benchmark. This is only for first time. You have to take the RL benchmark. Here RL of change point plus backside 49.705 plus 1.850, you will get new HI, that is 51.355. So 51.355. Okay, our new HI. Now you deduct your IS value 1.935 from this 51.355. You will get RL of this station number 4, that is 49.620. Now you have to deduct this IS value 2.450 of station number 5 from new HI, that is 51.355. You will get RL of station 5, that is 49.105. Then for station number 6, you have to take foresight value 1.750. You have to deduct again from the 51.355. You will get RL of 6 number station 49.805. Now you can see here again change point is there, and whenever change point is there, you have to take new HI, means you have to calculate new HI. So 49.805 plus backside value, RL of change point plus backside value, you will get new HI, that is 50.165. And once you get new HI, same way you have to do the same procedure. Your IS value for 7 number station 0.720, you will deduct this value from HI value 50.165. You will get RL of station number 7 49.445. Then you have to take 1.200 foresight value. You have to again deduct from this value, that is new HI 50.165. You will get 48.965 for station number 8, RL of station number 8. Then again your change point is taken, so you have to again take the new HI. You have to again calculate the new HI. So how will you calculate? 48.965 plus 0.920, that is 49.885. And then only one reading is there, 0.630, that is foresight. You will deduct from this 49.885. You will get new RL, that is 49.255. So you already done your all the calculation. Just take the summation of all the BS value. Just take the summation of all the foresight value. This is your last RL. This is your first RL. So that is this arithmetic check. Summation BS minus summation FS is equal to last RL minus first RL. 3.480. Okay. This way. 3.480 and 4.225. 4.225 is equal to 49.255 minus 50. So you can say, see here, minus 0.745 is equal to minus 0.745. Both the side you are getting the same reading, means your arithmetic check is okay, your example is okay. Now same example I have done using the rise and fall method. Same example. You can say station are given, channels are given, backside, IS, foresight we already entered. We have calculated summation also, summation BS, summation FS. Now only this portion we have to see here. Instead of HI, I have had two column, rise and fall. So same way that we already discussed, you have to take the station number 1 and 2 level difference 0.3450 minus 0.580. Because we are taking the difference, means that's why I have done the minus 0.350 minus 0.580. So you will get one value, that is the negative one, that indicates the fall, that is 0.230. So you have to enter in a fall column. This indicates that there is a valley. Now you have to take this station number 2 and 3 level difference. So 0.580 minus 0.645. Again you are getting the negative value, means that indicates the fall. You have to enter in a fall column. Means there is a fall. Now again here change point is there. So you have to start again from this point. So station number 3 and station number 4, you have to take the difference of this two value. You are getting again the negative one, that is the fall. So you have to enter here. Then you have to take the station number 4 and 5 difference. Again you will get the negative value. You have to enter in a fall column. Then you take the station number 5 and 6 difference, level difference. Here you are getting the positive value. So you have to enter in a rise column. That indicates that here there is a hill area. Again here change point we have taken. So again you start from this station point number 6 and you take the station number 6 and 7 difference, level difference. So 0.360 minus 0.720. Again you will get negative value. You have to enter in a fall column. Don't put the sign because already we have put, just put the value. Then 7 number station, 7 number 8, you have to take the level difference. Again it will come. Here I think so 0.720. Yeah, again it will become negative. So you have to enter in a fall column. Again change point. So again you have to start from here and you have to take station number 8 and station number 9 difference. And that will be positive. Okay, so 0.290, actually there is one mistake. You have to put this 0.290 here because 0.920 minus 0.630, it will be positive value. So I have done one mistake. So you just consider this value here. Okay, and then take all the rise value summation, then all the take fall value summation. Now come to the RL value calculation. So RL benchmark is already given. You have to deduct your fall value 0.230 from 50. You will get 49.770 RL of station number 2. Then 0.065, you have to deduct this fall value again from this RL, not from 50, current RL. So 49.770 minus 0.065, you will get new RL, that is the station number 3, 49.705. Then again 0.085 you have to deduct from 49.705, you will get 49.620. Again 0.515 you have to deduct from 49.620, you will get 49.105. Now here you have to add this value 0.70 from this current RL value. So 49.105 plus 0.700, you will get 49.805. This is the RL of station number 6. Now to calculate the RL of station number 7, you have to again deduct 0.360, that is the fall value, from this RL 49.805. So you will get 49.445. Again you have to deduct 0.480 from 49.445, you will get 48.965. And again 0.290, you have to deduct from 48.965, you will get 49.2. This is your last RL, this is your first RL. Then once you do all the calculation, you can see you have to do the arithmetic check, that is summation BS minus summation FS is equal to summation rise minus summation fall is equal to last RL minus first RL. Summation BS we already done. Okay, that is 3.480, 4.225. 4.225 is equal to 0.990. You can see 0.990 minus 1.735 is equal to 49.255. This is the last RL, 49.255, and this is first RL, that is the 50. Just take Just check points. Minus 0.745 is equal to minus 0.745 is equal to minus 0.745. Means you getting all the calculation is okay. Means your arithmetic check is okay. Your example. So friends, today I found all the two methods. That is the rise and fall method and height of instrument method. How to do the calculation. And I hope that you understand these all the things. Okay friends. So now I'm concluding this video. If you have any query or any doubt, you can contact on my email ID. Just write down my email ID kbpatel kbpatel 99 again 99 again 9 99,999 kbpatel 99999 @gmail.com. Thank you.